We'll be going over Leetcode problem number 3, longest substring without repeating characters today. We'll start with the problem readout, go over some whiteboarding, and then we'll write out the code for the solution. So let's start with the problem readout. Given a string as find the length of this longest substring without repeating characters. So it says longest substring. When you see something that asks for the longest or the maximum or minimum and it's a substring, chances are you will be able to use the sliding window pattern. So substring means these elements will have to be contiguous, meaning they have to be next to each other. So that's why we'll be able to use the sliding window pattern. So let's look at a few examples here. We have S, that is the string, ABC, ABC, CBB. So we don't want repeating characters. So this is a unique set of characters, but then here A and A are the same, so we start again here, ABC, and then BB. All right, the answer is ABC with a length of 3. Cool. For example 2, we have BBB, 1, okay. Always check out the constraints. S.length is 5 times 10 to the power 4. S consists of English letters, digits, symbols, and spaces. All right. So here's what we're gonna do. The idea here is to keep track of the range of elements that we're checking, and that range will be checked using this window, meaning we will have 2 pointers, one at the start. So this is window start. I'll call it WS for short. And then another pointer for window end. I'll call it WE for window end. WE. So first we'll initialize our pointers at the window start and windows end to 0. That is the first element. We'll also initialize the max size to 0, so no matter what the size of the window we find, it will always be greater than this. So we'll be replacing this with the maximum that we find. We'll also have to use a hash map to keep track of all the elements that we have seen before. That way we won't be including any duplicates, right? So let's walk through a few iterations and see how this problem will pan out. When I'm at this position, I will first check whether I have this character in my, or whether I've seen this before or not. If I look at my character map, I see that it's empty, which means I haven't seen this before. So what I do is I just add A and initialize it to window end's position, which is 0 at this point. We also recalculate the max size. So at this point our window size is 1, and window size is calculated using this formula. So window size is equals to window end minus window start plus 1. And the plus 1 is because string indices are 0 indexed, but we want the length of the window, not the index position or the difference between indices. So that is why we have the plus 1 here. Great. So for this thing, our max size will be maximum of my current max size plus the window size. So whichever is the maximum here will become my new max size. In this case, it will be max of 0, 1. So this will be equal to 1. and then we'll move our window to the next position. So if I just copy this and I'll also copy these so you have a reference to them. Great. So at this point I'm moving my window by 1, which means this will increase by 1, and we have this. Right? So at this point I have to go through the same motions again. So I'm checking, is B in the character map? It's not, which means I still haven't seen any duplicates yet. So I'll do B and save its index, which is 1. Right? And at this point my my max size would be 1 from the previous calculation. Now I'll have to recalculate max size again. Similarly, I would do max size is equals to maximum of max size, and then window end minus window start plus 1, which is equals to 1, and then 1 minus 0 plus 1, which is 2. Therefore this will be equals to max of 1 comma 2, which is 2, and you can see here that the size is 2. So let's do a couple more iterations so we can see the other case for this. So if I copy this here, I'll also copy my character map. Oops. I'll copy my character map here. Now this will be at the second index position, and then I will have to move this accordingly. So I move this here. So now I run through the motions again. Do I have this in my character map? Which means, have I seen this before? I check my character map, C is not in there. So I add its position in the character map, and then I find the new maximum size. Again, the new maximum size will be maximum size and max of max size, and then window end minus window start plus 1. I won't go through the entire calculations again, but this will be 3. And from the previous stage, this will be 2. Now the next iteration will be a bit different, so let's check that out. At this point our max size is 3 and we have this character map. Now if you look at the original string, we'll move this to the next position. So if I move this to the next position here, to the third index, now we run into a different scenario, and that scenario is we have a duplicate here, right? So if we have a duplicate here, what do we do? So if I check my character map, I do see that I have A in here. Now at this point I have to shift my window, right? So I've been using the same window start since the beginning, but now that I found a duplicate here, that means I have to shift my window start, right? And how do I do that? So the way I do that is I take the maximum of the current window start. So I would have to update my window start. So I update my window start, and this will be equals to the maximum of window start. I'll just call it WS for short. Window start, and the character or the last index of the character, that's the duplicate, plus 1. So this means I want to start the window right next to the duplicate that I found at this point, which means I don't want to keep it at the 0th position. I want it one index forward, which means I will do so I'll access car map A plus 1. At this point it'll be 0 and 1, so my window start will be 1, which means at this point I will move this here and I will move this up to here. As you can see, this way my window always has non-duplicate characters, right? Which means I get to recalculate the window sizes again, right? Like before you do that, always update the index of the character that you are at. So instead of 0, this would be at 3. This is now at 3. Again, I'll have to calculate the maximum size. So maximum size is equals to max of max size window end minus window start plus 1, and this time they'll be the same. So my current one is 3 and this one is also 3, so 3 minus 1 plus 1 is still 3, so my window size hasn't changed, right? So that's the basic idea behind the solution here. So let's go back and code this out. So I said I'll have to initialize a car map to keep track of my characters. I'll have to keep track of window start, so I'll call it window start, which is at 0. I'll also initialize window end, which is at 0, and then I'll initialize window size, which is also at 0. Now I'll run through all of this iteration until window end reaches the last character of the given string, which means window end will be less than s.length, and then I'll just do end car to keep track of which character I'm currently working with. So the first step I did was I checked whether that character was in the map or in the character map. If it was, then I did something, otherwise I did something else. So let's do the scenario where I don't have the end car in my car map. That way it'll be easier. So first, if I don't have it in my character map, the first thing I want to do is I want to add it to it, right? And then I'll calculate my current window size, which is window end minus window start plus 1. And I'll recalculate my maximum size, which is the maximum of max size and the current window size. And then finally I'll increment window end by 1. You can also use a for loop here if that makes easier for you, but I'm using a while loop. So what happens when the map character is in the map? So for that scenario, what we did was we just adjusted our window start, all right? And that is exactly what we'll do. We'll take the maximum of the window start or the character index, and we take the maximum because if we already have seen the character, right, we want to take the window after that character. So what we do is window start is equals to math.max window start, and then the position of the character plus 1. And then finally, once we go through all of the characters in S, we will return max size. So if we run this now, we can see that it is running the test case. Let's try submitting it. and we get the solution. So the time complexity in here will be O of n because you're going through the S array once. And the space complexity will be maximum of S dot length because all of them can be um, non-duplicate, so you would end up storing the entire length of the string inside the car map, or at least have all of the characters in the car map. And since it says this S can consist of English letters, digits, symbols, and or spaces, which means it won't be limited to like the alphabet character set. So it can theoretically be infinite since we can use numbers, right? So time complexity of n and space complexity of n as well, n being the size of the string s. So hopefully that was helpful, and if you have any other solutions or suggestions, please ask them in the comments. See you next time.